Number 9, we're given the function f of x equals 2 divided by 7 plus x. We have two parts, A and B. A says find the inverse and check your answer. And then B, find the domain and range of f and its inverse. Okay. When you want to find the inverse, replace this with y because that's what it really is. Alright, so we're going to say y equals 2 over 7 plus x, and then you interchange x and y. Okay, so we're going to just switch places with x and y. So x equals 2 divided by 7 plus y. So I took this equation, I switched x and y, and then you're going to solve for y. So now we're trying to get y by itself. Alright, so the way that we do this is we're going to multiply by the denominator to get it off the bottom. Okay, so I'm going to start out by multiplying by 7 plus y on both sides. 7 plus y. Alright, so it's going to get divided to be 1. So I have 7 plus y times x equals 2. Alright, now we're going to divide by x to get this away from the y term, and that goes to 1. Alright, so now we're just left with 7 plus y equals 2 divided by x. And then lastly, to get y by itself, we have to get rid of this 7, and it's positive, so we have to subtract it. So subtract 7 from both sides, and then that goes to 0, and then you have y equals 2 divided by x minus 7. So this is what we're calling the inverse. We're saying that f negative 1 of x, f inverse of x, is equal to 2 divided by x minus 7. So this is the inverse. Now we have to check it out. So when they say check, we're going to plug this in here, and we should end up with x. So notation wise, we're going to do f, and then in place of x, we're going to do f inverse of x. So we're going to be plugging this new equation that we just got down here. We're going to be plugging this in for x. 2 divided by x minus 7. We're going to be plugging that in. So we have 2 over 7 plus x, but x is going to be 2 divided by x minus 7. Alright, so we can't do anything inside parentheses, so we can just drop them. So that gives us 2 divided by 7, and then plus 2 over x minus 7. So the positive and negative 7 will divide each other to be 0, and then we're left with 2 over 2 divided by x. Alright, so no such thing as dividing by fractions. We're going to do keep, change, flip. So keep the top, change the multiplication, and flip this guy. So it'll be x over 2, and 2 divided by 2. 2 times this divided by 2, we just get x. Okay, so it checks out that is in fact the inverse. Okay, so the inverse is 2 divided by x minus 7. So again, you just switch x and y, and that gives you your inverse. Alright, so find the domain of f. Alright, so this is the original function. That's this guy here. So since we have a fraction, we have to set the bottom not equal to 0 and find out what makes that 0. So I'm going to do that up here in the top. 7 plus x cannot be 0. So if you subtract 7, you get that x cannot be negative 7. So negative 7 will cause us a problem that will give us 0 in the denominator. So as far as our domain is concerned, the domain x cannot be negative 7. Let me make sure that is the right response because there's several of them here. Why is it so teeny? Let me see. Alright, I can see a little bit more of this. That one says the domain is x cannot be 7. That's just x is less than, x is greater than, and all real numbers. Okay, so we have the right one. X cannot be 7. The range. So this function is comes from the parent function of the reciprocal, which is the parent function, which I think you guys have a worksheet of the parent functions, is 1 divided by x. Okay. This graph has a horizontal asymptote at 0. So the graph does something like this. It comes from this area. That's just a general form of the parent function, and does this. Okay. Now when we have pluses and minus, we shift this guy over. In this case, the parent function did not get shifted up. It doesn't have a plus anything. This 2 would just stretch it out, would stretch out the graph a little bit in the vertical direction, and then this positive 7 would shift it. So this graph would have got shifted over. Positive 7 went to the left. 1, 2, 3, 4, 5, 6, 7. So it'll be a asymptote right there. So the range, the only value that we don't get is 0. You see how this line doesn't cross this axis, and it just comes from that parent function of the reciprocal graph. So the range cannot be 0. I think we did go over horizontal asymptotes and things of that nature in a previous section. So you might have to default back to that. Let me see what I'm missing here in the middle. See, this says greater than. So it just cannot be 0. We can get all the other numbers. And then now we want to find the domain of f. Okay. Or f inverse. So right here, this graph, we cannot have 0 on the bottom, so x cannot be 0. It's just kind of given. So x cannot be 0. That'd be this option number C. X cannot be 0. And in the same instance, what is our range? So the graph is going to look the same reciprocal identity with x on the bottom. However, this minus 7 is going to shift your graph down 7 units. So you would have something like this. Here's the x-axis, and we go down 1, 2, 3, 4, 5, 6, 7. So your new horizontal line would look like this, okay? And your graph would not cross that line. So it would go across the x-axis, but it won't cross this line y equals negative 7. And it does the same thing, say the same general shape, because that's the parent function. So this time negative 7, okay, y equals negative 7, we cannot cross that line. So that number will not be in our range. Y cannot be negative 7. So all of this is kind of coming from when we talked about transformations of graphs, when we shift, and then also the horizontal asymptote, vertical asymptote, and being familiar with the parent functions.